What's up everyone, welcome to this instructional video on how to build this CNC plasma cutter yourself. So this is my CNC plasma cutter, and if you're watching this video, that means you've bought my plans to build this machine yourself. So thanks for buying it, and in this video I'm going to show you basically how to build this machine. The main video was, well, a bit short and I've left a lot out. So this video is not going to be as entertaining as the other one, but it's going to have a lot more information. So first thing we're going to do is basically go over this machine, show you how I've built it, show you some details of it, which you might want to know if you're building this machine yourself. And then once that's done, we're going to talk about some dimensions and some build stuff. And then we're going to go into the main topic of this video, which is wiring the motors, the breakout board and stuff, and basically get it moving. So what we're going to do first is basically get a single stepper motor and a stepper driver and a breakout board and a laptop, wire them up in such a way that you can control the motor with the keys on the laptop. And once we've done that, you basically can do it 4 times, because there's 4 motors on this machine. And once you know how to wire up one motor, you can wire up 4 motors, because they're all pretty much wired in the same way, just some longer wires. And then we have a stepper motor we can move with the arrow keys on the laptop, which is honestly quite cool and a big step. So once we've done that, I'm going to show you how to load the G-code and set up the machine so you can actually cut apart, but that's later. First I'm going to talk about this machine, and then we're going to go in some more depth on the software like SheetCam and Mach 3, the settings you need, how to cut an actual part, how to set up the machine to go with Mach 3, but that's all later. First we're going to talk about this machine. So some basic features of the machine. This axis, this one, the long one, is the X-axis. X. Alright, so I'm going to reference that a lot. X-axis. This one, Y-axis, the Y-axis. And then up and down, the short one is the Z-axis. Alright, so remember that. The X-axis has 2 motors, one on this side and one on the other side. You can't see it, but it's there. Now in software, this motor will be referred to as the X motor, but the other one will be a slave, basically do the same thing as this motor, to the X motor. And it's going to be called the A motor. A motor. So remember that when we talk about motors and stuff: X motor, A motor, Y motor, Z motor. So that's that. Now this machine has a 2x1 meter cut capacity, which means it can nicely fit a standard size sheet, in Europe at least, of 1x2 meters. If you live somewhere else or have limited space, or you want to cut even bigger, you can make it basically as big as you want, as I've said in the main video. So what you're going to do, basically extend the rails, make it wider, longer, shorter, narrower. You can do it all, doesn't matter. And then we can just adjust the software really easily to accompany the small or larger machine. Just keep in mind, this machine has a 2x1 meter cut capacity, but the bed is actually 110 wide, because you need the extra space on both sides for all the mechanic stuff. And also the bed is 20 centimeters longer than the cut capacity, so the bed is 2 meter 20. So keep that in mind if you're changing dimensions. Keep the bed 20 centimeters longer than the cut capacity and 10 centimeters wider than the cut capacity. Alright, all that stuff is also in the plans, so don't worry about it too much. Like I said in the main video, the mechanical part isn't all that difficult. These parts are laser cut, they only fit together one way basically. This is just some box section, this is just some sheet and some strip. The linear rails, just need to make sure they are parallel to the box and to each other. Same as this one. I've shown you how to extend the linear rails. For the gear rack, you can basically use pretty much any gear rack. This is a Module 2 gear rack, but Module 1 or Module 1.5 should work too. If you're in the US, just look up the pitch, which should be approximately the same. I have it linked in the video description. So that's basically the introduction. Next thing we're going to do is take a closer look at some parts of the machine, show you around a little bit, and then we're going to start with the wiring. Alright, so looking at the machine, I think I've shown pretty good how to build most of it in the main video. One few things I did add were these stabilizers in the corners to make the frame a bit more sturdy, because when the gantry moves it tends to shake a little bit, so this solves that. Also, this is just a strip of metal welded to the box section, and it's used to guide this cable guide, and I've added a strip on the back side so it can't roll off on this side and hit this part, because it does roll all the way up to here. Now it doesn't need to be any longer than here, but I've extended it anyways because it makes for a nice cable tray, but it can be just here and then go both ways. So the bed, so the water pan, I did add some strips underneath there to make it a bit stronger, because it was flexing a little bit and I don't want a curved bed. So that's some of the few things I didn't mention in the main video. I did show the strips. They go into the slots which I've cut in the water pan, and they bend in like this. All of this will be explained in the plans too. Now for the actual moving bits, this is the floating head, and I didn't show how it's mounted on the Z-axis, but basically behind here is just one of those super small linear guides. I'll just show a picture of it right now. Yep, one like that, and it moves a switch like this. Now you don't need to use this actual switch, but it works pretty good and you can adjust it. And the height between the end and the way this thing stops and doesn't fall off the bottom here is because this is an Allen key screw which goes into this plate, and I've added one on the bottom there too. I don't know if you can see it, but basically the rail just hits the Allen key on the bottom here, and therefore it doesn't go all the way down. Now it doesn't need to move any more than this, and this movement, the distance isn't that important. You can adjust it in the software later, because of course it is important for the machine to know the height of the material, but you can adjust it, so it should be somewhere around 10 millimeters, but it can also be 11 or 12 or 5 or 6 millimeters, doesn't really matter. Then for the Z-axis we use one of those Chinese ball screws. Everything will be of course in the plans and in the shopping links. It's bolted to the gantry, and this motor drives with one of these couplings, which is also linked. All the parts are linked in the video description, so just don't worry about it. But anyways, that couples to the shaft, and then that mounts to the moving bit of the Z-axis. Now for the Y-axis, the motor is right here, and it runs in this gear rack, so it's vertical, and you can see the pinion here. And I drilled the holes right through the gear rack and just filed the edges down a little bit. Doesn't matter, runs really smooth around there. And a rubber washer around here, so I can tension it, and if there's something in here like a bit of dust or something, it can run over it instead of jamming it. And this nut is the actual hinge of the motor, and it should be just tight so it can move freely, but there should be no play on there. And really that's the same for this motor, and of course the A-axis on the other side. This is the hinge point, and this is the adjustment point, and again a rubber washer under there to have some compensation if anything happens, and also to get rid of the play. And this is really nice, there is no play in here at all. And I currently have this switch loose because I was using this to do the wiring to show you how to do it. But this will go on here, and this is the home switch for the Y-axis, so this will move in this direction until it hits this switch, and then it will know where the home is of the machine. All will be explained. Same switch will go on here. Currently I have one of these micro switches on here, but I will change those for these as well. And those switches indicate the home of the X and A axis, and that's pretty important because the gantry needs to be square to this movement, or else your parts won't be square. So the way I square the machine, because this isn't perfectly square to begin with, and I can actually move this side a little bit with the machine turned off, where this side is still. So currently I don't have power to the stepper driver, so the motors are free to move, but I can feel this side moving a little bit while that side is not moving, and vice versa. So basically, when the machine homes, it will hit this switch and a switch on the other side, and if it's not perfectly square, this axis will go on till it hits the switch, and then it will be perfectly square. That's important. I will tackle it again later, but just know that that's the way everything squares up. Of course, you should build it as square as possible, because if it's really off, it's not going to be able to square it. It's going to have a tough time running and stuff. So, but anyways, that's it for the limit switches. So another one on here, another one on there, and these two. So basically 4 limit switches on the machine, which is all we need because we only have 4 input pins on the breakout board, and I'll show you all of that later. This is the electrical box. It's a metal box, and it has an opening on the underside where all the wires will come out. And this is where I have my laptop right now, and this is obviously a temporary table, but everything is controlled via USB, so it should be pretty close to this box. I don't advise using a longer USB cable and moving the laptop further away from the machine, because it might not work, because the USB, well, it doesn't like a longer cable. So don't do that, and just move the machine close to the laptop. I'm gonna make a laptop stand here later. So, alright, so what else can I tell about the machine? The plasma torch, yeah. This goes, of course, to the plasma. You can use a machine torch as well. There is space around here to do that, but this is probably cheaper and more common. So I have it wired like this with a tie wrap around here, just so when this cable gets jerked on, it doesn't move the cutter head, and this goes to a screw in the wall. Obviously this is not ideal. I'm gonna make a crane which mounts on the wall later to basically hold the cable around here, and then it's free to move in all directions. Really simple, but just haven't got around to it yet. So just keep in mind, this cable should be somewhere in the middle. So, plasma cutter, nothing really special. Ground clamp you can put on the material or somewhere on the slats, or even on the other side of the table. And I have wired this cable into the plasma cutter, which is used to switch it on and off. Of course, the machine will have to switch on and off the plasma cutter. So it goes in the machine here, and I'll show you how to wire that later. Should be the same for pretty much any plasma cutter. So yeah, that's basically it. This is the machine again, and if I plug it in, I can move it with the keys, so let's do that. Now, just to show you, I've just plugged in the extension cord going to the driver and the power supply of the plasma. Now, start it up, Mach 3. Only thing I need to do is hit reset around here, click it, and now I have access to the machine and I can move it. Look, there it goes. Also the y-axis, like this. And then using the page up and page down controls to move the z-axis. There it goes. And you can set all these moving speeds in Mach 3. I'll show you later. For now, let's do some wiring and see if we can get a motor turning with the laptop. Alright, so let's start wiring a single step motor so we can control it with the computer. I'm gonna talk a little bit about the components we need, of course the wiring, computer stuff. I'm gonna explain everything. So, first thing we're gonna start off with is the power supply, of course. Now, this power supply is 24 volts. The whole system runs on 24 volts DC power. This is 24 volts, 15 amps. So that's enough. So 24 volts, 15 amps. Looking at the connections. This is of course our main voltage in from the wall socket. In Europe it's 230 volts, in America it can be 110 volts. Doesn't really matter. Just get the one you need. So this is obviously ground and then neutral and live. Obviously wire all this stuff without anything plugged in. And that's the same when you're doing any wiring on anything. Don't plug it in and don't touch it when it's plugged in. So plug in these wires. I just got an old extension cord, cut off one part, wired them in here, and then the other part still has the plug on it, and I can plug it in the wall socket. So that's that. And then this side is the 24 volt side, so we got 3 outlets with 24 volts the negative and 3 with the 24 volts positive. So next main component is the breakout board. This is basically the heart of the machine. Everything will be wired into this, and then this will be connected to the PC with a USB cable. It's really not an expensive board, but it's, well, pretty good for what it is. So you can also get this type of board, which has a parallel port connection. This is actually just the power, not the connection to the PC. And you can use a board like this, but I couldn't find any computer anymore with this type of port. So that's why these type of boards usually aren't used that much anymore. But you can still use it, but everything is going to be different. So I really advise you use the red one. Basically, if you get a red one with the USB, you're good. This is the one. So, looking at the breakout board, USB port, this is for another control. We're not going to use that. We're going to use this side and this side. Now, really important, this side is the 5 volts side of the board. So everything in here is 5 volts. This side is the 24 volt side. It also says it right here. 24 volts, 5 volts. Don't connect 24 volts to the 5 volts and vice versa, of course. So the nice thing about this board, everything is written on here. You can actually see 24 volts, and on all the input and output pins it has a short description. So if you mount this in a steel box, of course make sure to isolate it from the steel, because you will short circuit everything if you don't do that. I'm gonna mount it on this piece of wood so it doesn't move while we're wiring it. Alright, next part is the stepper driver. The power converter, which takes signals from the breakout board, steps up the power and sends it to the stepper motor. This is the input signals. This is the output signals to the stepper driver, and 24 volts in. Again, this is the 5 volt side. This is the 24 volt side. Don't connect 5 volts to 24 volts. Now for the settings, if you get this exact model, make sure this switch is flipped to 5 volts right here. You can see it on here. Yes, 24 volts, 5 volts. Make sure it's flipped to the left side if you're using this breakout board, because we're using 5 volts power on this. If you don't do this, it won't work. Then these switches, don't worry about it too much. Just flip 7 and 8 down and the rest up. So everything up, 7 and 8 down. That's it. Okay. Next up, stepper motor. Stepper motor, use this kind of stepper motor, the exact one. Don't use a smaller one, it won't be powerful enough. This is a 4.2 amps, 3 Newton meter stepper motor. It has 4 wires, blue, red, black and green. This will connect to the stepper driver. I'll show you how later. That's it for the stepper motor. I'm gonna put a piece of tape around here so we can see if it moves. Okay, so I got the breakout board mounted on my piece of wood. Now first thing I want to do is mount the 5 volt side to the 5 volt side of the stepper driver. And the only 4 ports we're going to worry about is pulse plus, pulse minus, direction plus and direction minus. We don't need any of these 4. Alright, so that said, this is again the 5 volt side of the breakout board, and there is some writing on here: AP, AD, ZP, ZD, YP, YD, XP, XD. This stands for your axes, so A axis, Z axis, Y axis, X axis obviously, and then X axis pulse, X axis direction, so pulse direction, pulse direction. Alright, for this test it doesn't really matter which one we take. I'm just gonna use the X axis again, doesn't matter. So on the left side we see 5 volts, ground, ground, and in the corner 10 volts. Don't use the 10 volts, we only use the 5 volts. And the ground we also not gonna use. So this board will take 24 volt. It will make its own 5 volts power, so we don't need an extra 5 volts power supply with this board. So we're gonna wire up 24 volts to the breakout board on this side, so 24 volts in, and then DCM right below it means DC common, basically minus. So what we're gonna do, 24 volts to 24 volts plus, DCN, DC common to the 24 volts minus. That's the first thing we're gonna do, and then this breakout board will have power. Alright, so wired it up and got the power to the power supply. The green light is blinking on the power supply, which means we have power. But we don't see anything yet on the breakout board, and that's because we haven't plugged it in yet. If we plug it in to the laptop with the USB cable, we see a green light, which means everything is working. Now I suggest you move along with me at home just to get a hang of it and basically do the same wiring. And also see if you can get this stepper motor moving with your computer, and after you've done that you can start building and installing everything in your CNC. Anyways, that's the first step. Let's connect the stepper driver to the breakout board. Okay, so just unplugged everything again, of course. Now we're gonna wire our stepper driver. Now the weird thing is with these kind of boards, you don't switch the positive but the negative, which is kind of weird, because normally you switch the positive, but just follow my steps and it will work. So what we'll do, first we're gonna hook up the pulse plus and direction plus to the 5 volts plus, because we're switching, like I said, the negative. So 5 volts on the 5 volt side, this one, gonna hook it up to pulse plus and then jumper a lead from pulse plus to direction plus. Of course you can also do 2 leads or make like a junction box in between. Doesn't matter, just make sure they both get a pulse plus. And then once we've done that, we're gonna wire the negatives. So pulse negative to our XP, which stands for pulse, and XD will go to direction negative. So that's what we're gonna wire up. I'm gonna do it right now. Alright, so that's the pulse and direction all hooked up to the breakout board. Next up, we're gonna hook up this one to the 24 volts and then hook up the stepper driver. So first, I'm gonna take another one, positive and negative, and hook them up to the 24 volt side of the stepper driver. Ground will go to negative, plus VDC, voltage DC, will go to the plus, of course. So 24 volts to the driver. Alright, so next up we're gonna wire the stepper motor. This stepper motor will have 4 wires, and we're gonna wire them to these 4 pins. It's just the right pin to the right color. So the color combination is black, green, red, blue. So black on A plus, green on A minus, red on B plus, blue on B minus. That's simple. Let's wire it up. Okay, so that's all the wiring done for now. Next up we're going to do the computer stuff. So we're going to download Mach 3. And that's important because this board will only work with Mach 3. If you buy this board, you will also get a CD with it, which has Mach 3 on it. If you don't have a computer or laptop with a CD port anymore, you can also just download it online on the Mach 3 website. It's free. Once you've downloaded it and installed it, you will have these 4 emblems on your desktop. Mach 3 loader, plasma, Mach 3 turn, Mach 3 mill. Obviously we're going to use plasma. Agree to the terms. And now we have to, now we need to get a control device. So to run this breakout board on the PC, you need to install the control device driver. And if you go to the description of this video, you will find the first link showing a download where you can download the driver, and a link to another video which shows you how to install the driver. So go and click on the link, download the drivers, watch the video and install the drivers. Next you will have this option in this dialog box and you click OK with the R&R motion controller, which is what we need for this breakout board. Click OK. Pulse A all the way up to direction impulse X, and this is pin 1, 2, 3, 4, 5, 6, 7, 8. So basically we have pin 7 and 8 for the X axis, and 7 is our direction and 8 is our pulse. So with that we're gonna go into the settings of Mark III. This is one of the most important settings. Ports and pins, motor outputs, and then we're going to select the X axis, and then the step pin, like we just said, is the pulse pin, so that's pin 8, and then direction pin is pin 7. So step pin, pin 8, direction pin is pin 7, apply, and then we can close this. Then hit our reset button again, and now everything should move, which it does. If we hit the button, it will move. Now it might move very quick or very slow depending on the settings in Mark III. So to change that, you go to config, motor tuning, and here we can set the acceleration and the speeds of our motor. So that's down here. I have it in about 500 mil per minute and acceleration of about 90. If I change this to 2000 and then save axis settings, okay, it will spin a lot faster. See? So you can change that if it runs too slow or too fast. Doesn't really matter all that much for now. Later you're gonna want to set it according to your CNC. So change this back to 500, save settings, and that's about it. Okay, and now it moves at normal speed again. So that's how you wire up a stepper motor to a breakout board with the driver and a power supply, and of course Mark III. So this is the same for all the 4 motors in the CNC, except of course they will go in different pins. So the A axis will go in these 2, and the Z axis will go in these 2, and the Y axis will go in these 2. Then of course you will also need 4 stepper drivers which will be wired in the same way as this one, and of course the 4 motors with longer wires. You can just extend them with whatever wire you want, just remember the right colors and wire them up the same way. Now of course if you have 4 stepper drivers, you're gonna need 4 times this wire, and it's gonna be hard to cram 4 wires into this pin. So what I would suggest is you use like one of these Wago connectors or something else as like a 5V point into which you can easily put more wires, and where you can wire up all the stepper drivers. So what I will do now, if this is all working for you, is basically build your CNC, install the drivers, do the wiring, and install your motors this way. And that's about it for the wiring of the motors. Next up we're going to wire the switches. So as I've shown you before, we need 4 switches for 3 axis switch and of course the floating head. And I'm going to show you how we wire it up and set it up in Mark III using this breakout board. Right, so next up we're going to set up our limit switches. This is the switch I will be using. You can also use other ones like this one, or maybe even something completely different, but I found this to be very reliable and cheap and waterproof, because there will be some water spraying around from the plasma cutting. Anyways, we're gonna wire this one up. I'm gonna open up another one and connect it and show you how to do it. Okay, got the switch opened up. Now as you can see, when I move the switch, this is the normally closed terminal and this is the normally open terminal. So basically this one is always closed and this one will be connected when the switch is moved, so that's the one we want. So forget about these two, and we need the normally open and closed when moved terminals. So I'm going to connect the wires to here. Doesn't matter which way around they go, of course, with a switch. And we're going to wire it into the 24 volts port of the breakout board. And again, we're going to wire it in the reverse way as you would with a normal switch on a 24 volt system. So what we're going to do is start from the DCM, DC common, which is basically the negative of the 24 volts, and connect it to the switch and then wire it back to our import pins. Now we're going to need 4 switches, and to wire 4 wires into the DCM port is going to be pretty much impossible. You can also wire them from here, but this one will be full quickly as well. So what I'll do is connect one of these Wago connectors in between the DCM line. So basically this line just comes from the negative to this one to the DC common. So all of this is DC common. So I'm going to connect a wire from DCM, or this one, to the switch, normally open, then on this side back to the breakout board, to my input pins. So we have 4 input pins, in 1, in 2, in 3, in 4. Doesn't really matter which one you use for which end switch, because you can all change them in Mach 3. So I'm gonna wire this again, DC common, to the switch, to an import pin. So I'm gonna wire this one on pin 4 just to start. Okay, so the switch is hooked up. Basically, again, it takes the DC common, which is negative, switches it, and then brings it back into in number 4 or 3, 2, 1. Alright, okay, so let's test it. First of all, this here you can see diagnostics, and in this screen you can basically see all your input pins, output pins and stuff. And M1, M2, M3, M4 home will be our input pins. So if I push the switch now, nothing will happen because we haven't configured the input pin yet. So let's do that. So what we're going to do is do config, ports and pins, input signals. Alright, and here we have X home, Y home, Z home, and later on A home and B home. Now, in the CNC we are going to use A home. We are not going to use Z home because we're using a floating head setup. We are going to use X home and Y home. So for now I'm going to use X home for this test. So enable it. Port. All the ports are always number 3. So always port 3. Alright, and then pin number, well, the pin number which we set it on the breakout board is pin number 4. So we're going to enable pin number 4. And we don't need to tick any of these two because we just have a naturally open switch. So click on apply. Okay. And now we should go back to our diagnostics board. And if I hit the switch now, you can see M1 home lights up, which means it works. Now, like I said before, you can also change this to another port. So if you go again to config, ports and pin, input signals, and let's say you want to make this the Y home, we click this one, port 3, pin 4, apply, okay, and now you will see M2 home lights up when I flick the switch. So basically that's how we're going to wire up all our 4 switches. Doesn't really matter to which port you wire up the switch, you can always change them later. Really simple, just DC common switch 1, 2, 3, 4. So that's the home switches, and basically that's it. So we can now wire our motors and move them, and wire our input signals. So next up there's just one more thing to do, which is an output signal which we will need to turn on the plasma cutter. So let's do that one next. Alright, so this is my relay. Doesn't really matter what relay you take, as long as the spool side is 24 volts, just like our system. And then the switched side from the relay will go to my plasma cutter in a long cord. And I'll show you how to hook up this in a moment. But first let's do the relay itself. So these are the two wires which will activate the relay. And again, weirdly, we're gonna attach it to the negative side of the board. So that means one of the wires will go into the positive of the power supply, 24 volts. Then the negative of the relay is the ones we will switch, and this will go into an output pin. So out 1 to 4. Again, doesn't matter which one we pick. I'm gonna pick out 4 just because I can. So again, how we're gonna wire it. One of the relay wires, doesn't matter usually which one, with the relay, both will work. Will go to the positive, and the other wire will go to an output pin, and then the current will flow through the relay, through the board, and then back through DC common to the power supply. Let's hook it up in Mach 3 and test it. Alright, wired up the relay from positive through the relay to the breakout board, pin number 4. Alright, so let's hook it up in Mach 3. So basically the way we can test this is by hitting this button, torch on and off, which Mach 3 will do automatically if it runs G-code to turn on the torch on and off. So if I hit it now, oh, I can't hit it because I have to use a reset, of course. Now I can hit it, and the relay is not clicking because I haven't set it up yet. Alright, so back, config, ports and pins. This time we're going to go to output signals, and this is important, none of these output #1, this one. Alright, port number 3. In here we're going to put our pin number. Now again, I connected it to pin 4, can be any one of these. Pin number 4, apply. Okay, now hit reset and test it. So torch on, and I hear a click of the relay, and I see the light in the relay turning on, confirming it works. So that's it, the relay is working, and it will switch the wires from the plasma cutter, and I'll show you how to wire that up. Now to wire the relay, I just opened up my plasma cutter. Just gonna find the two wires which come out of the torch attachments. This one, that's of course the main voltage for the cutting, and then two other wires which will go somewhere to a breakout board in the plasma. And this is just the switch which you would manually switch with the hand torch. Interfere in these wires and just connect them to your relay. That's easy. And that's it, believe it or not, this is all the electronics we need to do. Just this, only a couple more switches and 3 more stepper drivers. That's all the electronics it takes to run this CNC. Alright, so next up, gonna put everything back in the plasma cutter and then set up some more stuff like auto homing and soft limits. I'll show you what they are later. But for now, this is all the wiring. Just do it 4 times and extend some wires, and then test your CNC. So, told you it would be pretty easy. So next up, put it in the CNC. See you again once I have it in there. Okay, got everything back in the control box. The breakout board connected to the stepper drivers and the power supply. I'll show you some more details of this later. First, I want to help you set everything back up in Mach 3. Now I deleted my profile, so I'm going to go through everything as needed to set it up. So let's go. Alright, so first important setting we're going to do is set our slave axis, the A axis to the X axis. So going to config, and then slave axis, go to the X tab, slave axis, select A, The rest should be none and none, and then click OK. And then it says you should restart Mach3 to take effect, so I'll do that, and that's that. Alright, so first thing I'm gonna do is go to ports and pins and do my motor outputs. So second tab, enable Y-axis, Z-axis and A-axis. And then I'm gonna put in all the pins. Just looking at the breakout board you can check, but this will be 6, 5, 4, 3, 2 and 1. Apply. Now I'm probably gonna have to switch the direction of one of the A or Y or pretty much any axis. I might have to change direction. So to do that I can uncheck or check one of these boxes. I'm pretty sure I'm have to change direction on the X axis, and that's it, I think, but let's see. For now this is good. Now for the input signals, I want the Y home active, not the Z home, but I do want the A home active and also the probe, this one. And then I'm just going to look at my circuit board and check in which pin I have each switch connected to. So everything is port 3, so this will be port 3 and pin number for me 2, but it depends on what you have. This probe pin port 3, pin 1, and then I have the X home on pin 4 and the Y home on pin 3. That's all alright. Active low we don't need to worry about if we have a normally open switch, which we do. So that's all good. That's the inputs. And then the output signal we already did, which is the output number 1, port 3, pin number 4 or any other pin. This is your plasma activator relay. So no need to make any changes there. That's that. And now I can move my gantry with the arrows as soon as I apply the power and put in USB. And then we can check if the motors are turning in the right direction. If they are, everything's good. If they're not, we're gonna have to change in config the direction. So let's try. Alright, got the USB plugged in and the power to the power supply. And now before I press any key and touch the reset button, I'm gonna go into motor tuning and make sure the X-axis and the A-axis have the same speed and acceleration, which they don't. So this one is 120 and 90 and the A-axis is 120 and 4, so I'm going to change this one to 90 as well. I'm not sure if it's good or not, but we'll find out soon enough. Save settings. The Y-axis is just gonna check the speed. Alright, seems good. And the Z, well, we'll see how fast they go. Anyways, but at least the A-axis and the X-axis are now the same speed, so they won't be shuttering in another speed and basically messing everything up. Alright, well, moment of truth. Reset. First I'm gonna touch this arrow key, and that moves the Y a bit fast, but it does move it. And now page up and page down will move the Z axis. Yep, that goes also pretty fast, but it does move. And now for the main X axis, it's also very fast and very shuttery. You can actually see the table move, which is because of the high acceleration, but they do move, and they also move in the same direction and in the right direction. So the right means it actually goes to the right, and same as for the Y-axis, it moves in the right direction, and the Z too. So if it's not the case, you can always change it in ports and pins, motor outputs and change this direction. As you can see, I have the X turned the other way. Of course, these two motors are mirrored of each other, so one always needs to spin the other direction than the other. So that's that. Looks good. Now I'm gonna change the speed a little bit, motor tuning. So the A-axis and the X-axis are the same, but they are a bit fast. Still, the motors are very fast. There's no way this is 120 millimeters per minute. And the reason is the motor doesn't know the gearing. It doesn't know if it's attached to a spindle or a big wheel or small gear, or maybe even a belt drive. So we need to set that. And that's the first thing to do. So how to do it? We go to settings. And right here in the corner you can find set steps per unit. And then it's going to ask us which axis we want to calibrate. So I'm going to do the Y-axis first, because we use the same gear rack on the Y-axis as on the X-axis. It doesn't matter, but this way I can do one and just whatever the outcome of this test is. This is basically just a test it does to set the increments per revolution of the motor for you. Whatever this outcome is, I can use it for the other motors as well. So what I'm gonna do, select Y-axis, say I want to move it, let's see, do 20 millimeters for now. Alright, click OK, it will move. Whoop, I hit the reset, it's moving way too far. Alright, so always be ready with that reset, because it was about to run off the rails here, or at least hit the end of the rails, which wouldn't be terrible, it just would make a terrible noise. So I'm gonna reset it. Obviously it was too fast, it moved 2 meters instead of 2 centimeters. So what I'm gonna do is go to config, motor tuning, and set this a bit lower, the steps per, which is basically steps per. It's basically the steps per revolution. So I'm gonna set this to 100 for now. 100. And save axis settings. Okay. And now I'm gonna do steps per unit again. Y-axis. Okay. And I'm gonna move it to 20 millimeters again. Oh, actually no, not yet. I'm gonna move it a little bit this way first. So using the arrow keys, move it this way. You can already see it moves much slower now, because I changed the setting in the motor tuning. So I'm gonna move it this way a little bit, because it's still gonna move that way and I don't want it to hit the other side of the gantry. Alright, so now getting back, settings, steps per unit, Y-axis, okay. I'm gonna say 10 millimeters for now. It's gonna move. And it moved, I'm not sure what it was, but it was like 50 millimeters. So whatever, I'm gonna put that in here for now. Okay. Yep. Okay, so this test is basically the test to set the revolutions per distance. So I just did 20 millimeter test to get somewhere near my eventual ratio, but you should test it way more and over a longer distance, because of course the longer the distance is over which you test it, the more accurate the results will be. So what you should do next is set it here, say I want to move it 500 millimeters, which would be to the middle, measure the distance, because it says what was the distance you actually measured, put it into Mach3, and that way you will have an accurate result. And the same result you can put in for the X and A axis. And I'm gonna put it in motor tuning, so go to the X axis and set this to 20. Save axis. Go to the A axis, also set this to 20. And again, this depends on your gear rack, but if you are in metric, it should be somewhere around 20, maybe 30, maybe 10, but somewhere around 20. Okay, so quick summary of the motor tuning I just did. First thing I did, config, select native units, make sure you're in millimeters or maybe inches if you want, no problem. Touch the keys, make sure motors do the right direction, and then make sure you don't go too fast. If they do go too fast, too slow, go to motor tuning. You can change the step spare, which should be somewhere around 24 millimeters, and then you can change the velocity again and acceleration. And you can play around with the settings some more. I'll show you what I have in the end. And after that we set the turns per revolution, so go to settings, step per unit, measure how far it actually moves, put in the number of what it actually moves, and you have your steps per unit. Again, longer distance is better. This will be the same as that one. The z-axis we do need to recalibrate. Same process, just measure like 5 centimeters. How far will it actually move? Put it in, it will calculate it for you, and you have your unit. So that's how you set your steps per unit and do your motor tuning. And now we have a nice moving gantry. It's still moving a bit slow, so I'll just put the motor tuning up to like 5,000 or something, which is a nice speed. And that's that. Okay, alright, so now I have my motors running at a reasonable speed. I'm gonna do the calibration test one more time. I have it set. So this is exactly 10 centimeters to this edge. And I'm gonna go into settings, set steps per unit, pick y-axis, say I want to move it 500 millimeters. Okay, and the y-axis will move. There it goes. And now I'm going to measure my value. And it's actually exactly 57. Minus, of course, the 10 centimeters we already have. Head makes 47, so I'm going to type in 470. Okay. And this is the number my steps per unit will be set to. Yep, except y-axis has been set. Now I go into motor tuning, and moving to the y-axis we can see here the number it just calculated for us. Copy it, Ctrl C, go to x-axis, paste it, Ctrl V, save axis settings, don't forget, a-axis, and also paste it here, Ctrl V, save axis settings. Okay, and now I've super accurately set my y-axis and the x-axis, and I know that when I move it 1 centimeter it will actually move 1 centimeter. Of course, very important. And now I also calibrate the z-axis, and these are the values. So 500 mil per minute is the speed. This is also 500, and this is calculated by the program in the same way. And if you use the same thread, you should be able to use this exact number. But you of course can also calculate it yourself. You should have around the same number there. Okay, that's the z-axis. So next thing we're gonna do is auto home using the limit switches. Alright, so I finished the motor tuning. Ended up going with velocity 5000 millimeters per second, acceleration 2000, and of course steps per 20. Gives me nice control. Reset, of course. Not too fast, but also not too slow, and not too fast acceleration. This is pretty nice. Alright, so next up I'm gonna do, like I said, the auto home. So I've connected all my switches to my import pins, and if we go to diagnostics, just like we did before, I can test all my input pins and make sure they correspond with the right. Okay, so that's that. Now I'm gonna do is ref all home. Just click this and it should go to its home. So, and it's moving, but it's moving in the wrong direction because this is where my home should be, and it's going the wrong way. So stop it, reset, click config homing/limits, click at this box, Okay, and that will reverse direction. Also I'm going to reverse one of the two of the X and the A. For now I'm just going to do the X, because of course, like I said, they are mirrored, so one will have to go the other way than the other. Click OK, and let's try again. Oh, reset of course, and ref all home. And there it goes. And now it's going in the right direction towards this switch. So for now I'm going to hit the switch with my finger as if it was home, and then the X axis should move. And now the X axis is moving, as you can see. It's coming towards me, so the right direction. Also the A axis. Now if I hit this, it should stop, but the A will continue. Oh, and there we have the problem. So, like I said, if I hit one, the other one will continue until it's square, which is what happened, which is good, but I didn't touch the other one, so that one continued. So let's rerun and resquare it. Okay, so let's move the gantry a little bit and let's try that again. So reset, ref all home. Okay, this is the y-axis moving towards the switch. This time I am going to let it hit the switch, so let's see what happens. Click, and now the x-axis will go towards the switch. Of course, I've tested it hits the switch before it hits anything else, which is important also for the other side. Let's see it hitting the switch. Click, click, and also the A-axis clicked, which means it's now home. And we can see that because all these three are now green. And this also means this is now our machine coordinates. So if I move this with arrow keys, you can see it adds up. So that's all good. And of course also this depends on your motor tuning and your steps per revolution. If you have it set up right, it should move, and you can check it with a tape measure. If it moves like, I don't know, 10 centimeters, it should be 10 centimeters. Check that, double check it, triple check it. Also for the Z-axis. Okay, next. And the nice thing about these switches is you can just change them a little bit if you don't like when they touch. So to square up the gantry, I might have to change this wheel a little bit, or change this one a little bit to make sure it's square. So test the square, just put a sheet in there, make sure the nozzle follows it in this direction and then in this direction too. If it's not, you can modify the switch a little bit to make sure it does square. So that's the reason we have the A-axis instead of just a copy of the X-axis. You can square the gantry. Alright, next up. Alright, so that's it for the homing. All these three are green, which means they have found their home. Well, not the C-axis, because we don't have a home for the Z because of the floating head, but at least the Y and the X have a home. And now we can set the limits, so the soft limits, so make sure this doesn't move too far and interfere with the other side of the gantry. Same for this one. So I'm gonna set the homing limits. Go to config, homing and limits, and then we're gonna go with the Y for now first, which is of course this one. Now it can move 1000 millimeters. I'm gonna be a little bit safe and set it to 960 for now. Alright, basically that's it. You can set soft minus to 0 because the home switch is minus, and click OK. So that's it. And now if I move the y-axis, it should not move over 960 millimeters. So let's see. Oops, that didn't go right. Okay, that went a bit wrong. I forgot to click this box, soft limits. Now it should work. And there it stops at 960 pretty much. So you can do the same thing for this axis and also set the home, so you'll never run it too far this way and basically override your switches and maybe break them. So that's the homing. It now has a home. It can't anymore ride off the tracks in all directions. And with this all done, it's time to work on the G-code and make this thing move on its own. Okay, so that's it for the settings in Mach 3. This is everything. Your machine is now up and running. We've set the limits. We've adjusted the steps per. We've homed it. Everything is done and ready to run a G-code. So next, let's make a G-code. So we're going to open up SheetCam. And first thing you want to do is add a toolbox. And I've added some tools in the downloads files with the plans. Doesn't necessarily make for the perfect tools to match your plasma cutter. Also doesn't make for the perfect to match mine, but it's a start. And you can always change the parameters like the cutting speed and stuff. So to add a toolbox, download toolbox, then go to File, open Toolset, go to your downloads box, and select this one or the one you've downloaded. Click Open, and that's it. And then we have your tool set right here. Okay, so that's the first thing we're going to do. Then the next big thing, this is really important to get the floating head to sense the material working. So you're going to go to Options, Machine, Post Processor, and here we're going to search down to find Mach 3 Plasma THC with scriber and backlash compensation. Really important. Click this one and then click on Edit Post. Alright, so here you can set all the parameters on which your G-code should set. And we don't have any backlash, so we're going to ignore that one. But we are going to change the switch offset, which is really important. So this is basically the offset, the distance which your floating head moves until it touches the switch and activates the switch. So measure it with some calipers, the distance between the 0 point of floating head and the point where it activates the switch. In my case, it's around 10 millimeters. I'm going to type in 10. All right, this is really important. This we're all going to ignore. Here we're going to leave nil. And then here on the ref home, we're going to set true. Also really important for the probe to work. Slow radius, you're going to go 0. Well, you can change it all later. This is like the slowing with the torch in like a small cut, like a bend or a gap. And the rest we're also going to leave nil and nil. And that's it. So save it right here. Okay. And that's our post processor done. This is really important to get the floating head working and stuff like that. You can, like I said, change some distance, like here, like the switch offset you can change here, or like the slow speed in a radius, and you can set the torch height control here, but we don't use torch height control on this machine because it can't handle this breakout board, so we're not going to use torch height control because you would need another breakout board. Anyways, that's it. So some other important settings, go to Options, Job Options. This is the rapid clearance, this is the height. The Z-axis moves over the material between cuts. I have it set to 20 millimeters just to be clear of any material. And this is 2 millimeters, and material thickness, it doesn't matter. Okay, save that. Alright, so now we're going to load a part. So we're going to go into here, File, Import Drawing. Select a drawing you want to do. So I'm going to go to Downloads. And I'm going to select a simple one. Well, let's do this one. Okay. Just click OK if it's in metric. Okay. And this is the part I want to cut, like a nice John Deere sign. What I'm going to do next is click here on this little icon here with a plasma torch with an arrow and create a tool path. Now here we're going to select our tool, and this is basically the thickness of the material you're cutting with the material you're cutting, so stainless or steel or aluminum. I'm going to cut it out of 3mm steel. And if you click this button, you can adjust the tool settings. And it was pretty high. This is the feed rate, so I've changed it down to 3500 millimeters per minute, which works pretty good for my plasma cutter. And the curve width you can change, which is the width of the actual cut. And you can change the plunge rate. I would set this to 300 for all of them. Cut height should be about 2 millimeters, pierce height about 4, and 0 pierce delay. Works the best for me. You can change around all these settings and just do some test cuts. And then we can use a lead-in, which is basically, it starts in the scrap part and then goes into the part. And you can find all this stuff on YouTube. There's a lot of information about this program. Alright, so I'm going to select the lead-in, arc 2 millimeters, OK. And then click OK on this one. And we have layers. Automatically sets layer 0. And this one is the outside offset, which is what we want. We can check it later. And now we click OK. And now you see it's made a tool path. You can see it here. And basically this is where it's going to start. First it's going to cut this there. And then it's going to go to the letters. So if we zoom in and click this one here, it shows the actual width of the path, and here you can see the lead-in in which it's going to start, and then the arrows, the direction of the cut, and you can see the cut is on the right side of the part, so in the scrap, of course really important, and also for the other parts, and on the outside perimeter it's on the outside of the part, so also in the scrap. That's good, and these are all the letters. So actually that's it for this program. Just select the tool, adjust the speed to what you want, which is really important, and you should do a couple of test runs before cutting a part like this, because probably it won't work the first try. So what I did was just take a strip of the material and make some lines and change the settings every line until you get a nice result. Anyways, yeah, that's it. So now we're going to do is click this button here, run to post-processor, save it. Well, I already saved it, so I'm going to replace it, yes. And that's it. One thing you should know, you can't use the free version of SheetCam to cut something this big, because you only can go like, I think 150 lines. You can buy the full version and then you can really easily cut stuff like this. You really need this program for the torch height control to work, so really advise to buy SheetCam. It's a really nice program, really simple, it makes the G-code in a couple of seconds. Anyways, again, that's it for SheetCam. You can set this to match your machine dimensions. There's a lot of information on YouTube you can check out. I'm not going to go into full depth. This is just how I do it. And now we have a G-code. So with that, that's it for SheetCam already. Really fast, really easy. So close SheetCam. And then we go back into Mach 3, set load G-code right here. And load the file we just made. Open it up. Take some time to load. And then here we see our little thing we want to cut. And this is the G-code. You can scroll through it here. You can change stuff in here, but it's not really easy. Wouldn't recommend it. Anyways, we hit this button, it will start. But first we need to say to the machine where to cut the part. So what I'm going to do is load some material, and then with the arrow buttons, of course first I'm going to home the machine again, because these are all red, which means it is not home because I just restarted it. So first I'm going to home the machine, then I'm going to move with arrow keys the gantry to where I want to cut the part from the sheet. And then what you're going to do is 0 the axis, so 0 this. I can do it right now. Oh, no, I can't do it because it's not in reset. So 0 the axis, you can see they go to 0, and then we can regenerate the tool path, and then it will cut the path where you want it. And then first we're going to cut it without the torch on, and then we'll do the actual cut with the torch on and make this sign. Okay, so the machine is turned on. I just hit raffle home, it's at home now. And you can see it because everything is green. Now I'm going to turn on the soft limits. Oh, I already have them turned on. And now I'm going to select where in the port, or where in the sheet I want to cut the part. So I have the sheet on there. I'm going to move it to where I want to cut it. So just with the arrow keys. Check out where the torch is.
And you're always going to want to cut the part in the bottom left corner. So this is where it's going to position it. So right now it's going to cut it around here. So let's say I want to cut it here. I'm going to set these three on 0, or at least these two. Regen the toolpath. And now it's regenerating it. And you can see the lines have moved. And now when I move it, this is the actual movement of the machine. So I can check, go to this side, if I'm still on the material, which I am not. So I'm going to change it a little bit. And now checking for the other axis, moving all the way up here. And it's over here, so it nicely fits in this material. Alright, so move it back a little bit. And now I'm just gonna not turn on the plasma cutter yet, because first, just to show you, I want to do a test cut. So the floating head is all in operation, and I'm gonna hit this button and it's gonna start. This is the probe working, and now it should be cutting if the torch was turned on. Alright, so it's moving, nice. I'll show you the probe again. And also in the post-processor setting you can set the distance to where it probes. So here's going to probe, touching the material, moving up till it hits the switch, moving down. This is the 10 millimeters we entered in the settings of SheetCam in the post-processor, so there it did a part. Now moving up to the 20 millimeters, moving down, probing again, up a little bit, the 10 millimeters, and that's going to cut again. And that's it basically. So 20 millimeters clearance height, you can also change that of course. And this time it didn't probe because it was very close to where it cut before, so there's no need to probe. And again, it's not going to probe, save a little bit of time. And maybe on the next one it is going to probe again. Yeah, there it goes. So probing again, moving up and cutting. So that's it. Machine is cutting. Now if your motor is moving the wrong way when you're probing, you probably didn't change the value in the post-processor of SheetCam from false to true, so change that and then everything should work. And here in Mach 3 you can see it running through the G-code and the progress it's making and what it's actually doing right now. And yeah, that's it. So it's just going to finish its cut, and next thing to do is just turn on the plasma cutter and we are in business. Now another tip, if you're halfway through cutting a part and something goes wrong and you hit reset and when I finish cutting the part, what you can do is go in the G-code, and then here you can look, see it moving around the white bit, and go this way to the part where the plasma cutter was when you stopped it, and then click and then look for an MO3 command. MO3 command like this one. Select it and then click set next line, and then if you hit cycle start it will start from here and you can continue the cut. So little tip. Alright, got the plasma cutter turned on, got everything set. I'm gonna start the cut. And here we go. Probing. That's it there, very nice. Alright, so that's it. You're now ready to start cutting. Yep, everything is working. Like I said, first thing I did was just make a G-code of a straight line and try some different cutting speeds, cutting heights, you know. Different settings on the plasma cutter, different settings on the air, until you get the best result with the least amount of slag. And you can change around with all these settings and just play with it a little bit, and you will get to know the software and SheetCam even better. If you have any questions, you can always hit me up on Instagram DM or send me an email, info@homewithmadness.com. And that's about it. So I'm going to talk you through the machine one more time. And this is the floating head switch, of course. Floating head is mounted on the mini linear rail. The way I mounted the plasma cutter is just by using this ring, which used to have two wheels attached to it to move the hand torch. Just welded that to this plate, but in the plans you will find another way you can mount the torch, but I'm sure you'll figure something out. Just make sure it's nice and square. Then of course the wire should be a bit higher. I'm going to change that. Not really that difficult. The motor stuff, all pretty simple and basic. Make sure they are nicely tensioned. There's no play. And then for the cable guides, I use 30 by 15 millimeter one and silicone cable. So these cables have 4 wires in them. So 4 and 4 for this motor and for this motor, and you can see the soldering connection around here. So 2 cables of 4 wires and then 1 cable of 2 wires going here to this switch, and then in the other cable guide we have of course these 2 wires, which I just explained, go to the cutter head, and then 1 more going to this switch, and then another one of 4 going through this hole to the other side of the gantry to the other motor. And there are all the cables. Oh no, of course also this one for this motor, another cable with 4 in them. You can see it here going through this one, and this one is pretty full, so if you want to add any more cable or thicker cable, you might want to buy a bigger one, but this just fits really nicely for me. And then the wires go into the box, come in on the other side, and I'll show you the box a little bit more. We have the 4 stepper drivers labeled which one they are, except this one, the breakout board and the power supply, and the wiring is just the same way as I explained to you, only 4 times. This is our common DCM. Like I said, a Wago connector on here. This is our 5 volts common going to all the stepper drivers, and then the USB cable, and that's about it. And of course power supply, make sure to earth the machine, ground it. It helps to avoid any problems with high voltage interference. And with that, you are ready to start cutting. Now, if you have any questions, again, hit me up. I will answer them, no problem, help you out. And I would say good luck tinkering around with this machine. It should get you started to do some test cutting. Don't go too ambitious on the first cut, of course. And well, good luck, and let me know if you've completed your build.